This is a circuit playground. It's a type of microcontroller, much like an Arduino. But unlike an Arduino, which has inputs and outputs running along the side, which you can plug into circuitry components and sensors, the circuit playground has its sensors built in, and it's got a whole lot of them, which makes it great for experimentation and ideation. These gold rings are capacitive touch sensors, which run around the sides. A little ways in from those are LEDs to give you indicators, or just make fancy light shows. There are a few buttons and a switch, which can help teach you a thing or two about toggles. A speaker, which can put out very basic tones. A microphone, which can pick up rudimentary sounds and changes in amplitude. A light sensor, which works with infrared light as well as RGB. A temperature sensor, which needs no explanation. And finally, an accelerometer, which is what we'll focus on today. So what we'll be doing today is taking the accelerometer data from the circuit playground and bring it into Unity to rotate a virtual object. This tutorial is a consolidation of a workshop run by Jason Aston at UMD's iSchool for IMD's New Works Incubator program. So in order to develop on the circuit playground, the easiest way to start is to download the Arduino IDE. So if you don't already have it, go to arduino.cc, click on the software section, and follow the link for your operating system to download. Once that's installed, you should see the Arduino IDE, Integrated Development Environment, and we're going to have to set this up in order to use it with our circuit playground. So there are actually two types of circuit playgrounds. There is the Express and the Classic. I'm using a Classic, but this tutorial will work for either. However, you'll need to set it up slightly different between the two. First, we need to make sure that our program is compatible for the circuit playground board that we're using. So if you go up to Tools, select Board, and I already have both boards installed, but if this is your first time using the Arduino IDE, you want to select Boards Manager, and that will pull up this Boards Manager, and then type in Circuit Playground, and follow that with either Express or Classic, depending on the board you're using. That will narrow down the list, and you'll be able to select it here and install. Again, mine is already installed. So once that's installed, you can go up to Tools, Port, and it should automatically recognize the port that your board is connected to. And so as you can see, it says Adafruit Circuit Playground, so I know that that is my board. Older versions of the Arduino IDE didn't do this automatically, so you would have to kind of figure it out on your own, but I'm going to go ahead and select that. And so once your board is installed, you're going to go back to Board and find your board in the list. The Circuit Playground Classic is going to be under Arduino AVR boards, and the Circuit Playground Express is under SAMD boards. I've got a Classic, so I'm going to select this one. Next, you're going to want to select your port, and the new Arduino IDE tends to automatically recognize and label the board alongside your port. But if you're using an older version of the Arduino IDE, you may have to kind of figure it out on your own. So I'm just going to select that to make sure that my port is right. And you can also see up here in this dropdown, it has designated a circuit playground is on COM4 port. So that's just another place you can select your port and board from. And now we can get to writing the code. So I'm going to write this code from scratch, but if you're trying to get up and running very quickly, you can check out the examples. So when you install your board, it's going to also install a library of example files. And if you go to File, Examples, and then find your board, you can see those examples listed out here. The Hello Circuit Playground examples typically give you nice little intros for each input and output of the board. But again, I'm going to do this from scratch just so you understand what's happening. So at the beginning, I need to import my Circuit Playground library. So I'm going to make an include statement. Include statements are for importing outside libraries or files. And so you say hashtag include followed by a less than sign, Adafruit Circuit Playground .h. That is the header file for the Circuit Playground library. I could also go to Sketch, include library, and find it there, and that would automatically add in that include statement. Next, I want to add some variables for my x, y, and z axes of the accelerometer. So I'm going to say float x, y, z. This will be a float because I want a decimal, and that decimal is going to give me extra accuracy. So now that takes us to our setup statement. Setup is what happens when the board initializes. So this only runs once, much like the void start function in Unity. So here I want to tell the Circuit Playground to begin a serial connection. Serial is a type of communication that the Circuit Playground, as well as other microcontrollers, use to communicate to the computer. So it is piping data from the board through the USB cable into the USB port so that the computer can use that data. So to start the serial communication, I'm going to type serial with a capital S and then begin. And then open up some parentheses, and here's where you put in the baud rate, meaning the bits per second, which the Circuit Playground will be communicating to the computer. So I'm going to use a baud of 9600 and then add a semicolon to the end and go to the next line. Next, we need to tell our board to begin running. So that is a simple command. It is Circuit Playground with a capital C and a capital P .begin. So this initializes our board, and that's all we need. Next, we can go to the loop function, and loop is similar to the update function in Unity scripts, where it is running over and over again. So anything written in here is just going to keep looping. And here is where I'm going to get the data from the accelerometer and send that data to Unity. So in order to get the x-axis data of the accelerometer, all I need to say is x. So I'm going to take our x variable and set it to the x-axis data of the Circuit Playground. So I'm going to say x equals Circuit Playground dot motion capital X parentheses. And it's as simple as that. We're saying ping the Circuit Playground and get that x-axis data from the accelerometer. And of course, I can get the y and z by copying and pasting that line and modifying the letter. So now our variables are going to hold that data from the accelerometer. But how do we get it to Unity? Well, like I said, we're communicating over the serial port. And in order to do that, all you need to do is say serial.print. And I'm going to put in my variable between the parentheses. And now we should be able to see the results of this code, the X accelerometer data. So just to test things out, I'm going to hit verify here. And what verify does is it compiles your code. So it gets your code together to make sure it can be uploaded to the board. And if your code is not yet compatible with the board, it will display errors. And that looks good. So I'm going to say upload, and that will upload the code directly to my board. Now I want to see if that accelerometer data is coming through the serial port. So in order to do that, I can go to Tools and Serial Monitor, and I can see here that that data is coming through. And as I tilt my board, I can see that it is changing. And one thing I'll also note is it's all printing to the same line. So these are really minus signs. They're not dashes between the numbers. So I'm just going to close that so I can add my other two variables. And in between the variables, I want the serial monitor to print commas. And the reason for that will become clear once we hop into Unity. So I'm going to put a comma between two single quotation marks. And that will add a comma between my x and y variables. So I'll add that y variable, then another comma. And last, I'm going to add the z variable. And instead of saying print for this last variable, I'm going to say print ln or print line. As I mentioned, when we were looking at the serial monitor, it was all printing to the same line. But I instead want my XYZ variables to print to a new line every time it records that data. So I'm going to go ahead and upload that. And then I'll open up the serial monitor and we can check if that's working. And as I tilt the Circuit Playground, you can see those variables are changing. So we now know that we have successfully gotten our variable data. And keep in mind, this is updating at 9,600 times per second. So this data is coming in very fast and it's very noisy data. So that's why you're not seeing the same number, even though my circuit playground is currently static. And we can always take those numbers and smooth them out through various different methods. I'm going to close that serial monitor because if it remains open, then it's going to block the data from getting into Unity. So every time you have the serial monitor open, all of the data is going to just go to that serial monitor. So if you're ever working with serial data, which you'll likely encounter for a lot of microcontroller projects, make sure that you close that serial monitor. Otherwise, your program may not work properly when it's actually running. So now we're ready to bring this into Unity, and so I have just created a default 3D program, and I'm going to take this accelerometer data and make it rotate just a simple cube. You could use any object here, but just to get started, I'm going to use a cube. So over here in my hierarchy, I'm going to right-click and say 3D object, cube, and there is my cube. And then just to get a better view, I'm going to click on my camera, and I can see my camera view here. But I'd like to be a little closer to that cube, so I'm just going to drag it over using the arrows. So we're going to add a script directly to our cube, and that script is going to bring in that serial data and apply it to our cube's rotation. To do that, I'm going to click Add Component over here in the inspector, and I'm just going to type in serial handler, and the only thing that will pop up down here is the option to create a new script. So it's going to take that name and create a new script from it. And so it's prompting me again. I'm just going to say create and add, and then I'm going to open up that script. So this program is going to act very similarly to our Circuit Playground program. And like our code written in the Arduino IDE, we will need to import a library. And so to get things started in our code, we're going to import the serial library. So I'm going to say using system with capital S.io.ports. And that will allow us to use our serial communication. Then under class here, we're going to set up some variables. And so first I'm going to specify which serial port we're piping the data through. And in my case, I am using the COM4 port. Your port may be different, especially if you're on Mac as opposed to Windows. So be sure you check which port you're using, and you'll need that for this line of code, which is serial port with a capital S, capital P. And I'm going to say stream equals new serial port, parentheses, and then in between quotes, I'm going to say COM4. Again, yours may be different, so be sure you are using whatever port is mentioned in the Arduino IDE. And then I'm going to put in my baud rate, which is 9,600, and then end that line with a semicolon. Next, I want variables to hold the X, Y, and Z rotation. So I'm going to say float, because again, we're working with those decimals. And rather than just saying XYZ, which might be confused for the position data, I'm going to say XROT, YROT, ZROT. ROT meaning rotation. And you'll also notice that both in here and in the Arduino code, I have declared these XYZ variables, not with one on every line. I've instead just separated them by commas. And this is just a shorthand for writing variables which you know might be related to one another, and you know are all the same variable type, in this case float. I can just say float and then separate those variables by commas in order to declare them, rather than taking up 3 whole lines to declare them each individually. So next we can go to our start function, and I'm going to say stream.open. That is going to open our serial stream, and that's all we need for the start function. So last I'll come down to the update function, and we want to read from that serial stream. So I'm going to create a variable to hold the values coming through that serial stream. So I'm going to say string serval. You can use any variable name. I'm just going to call it that. And then I'm going to say stream.readLine. Parentheses, semicolon. So this serial value is going to now hold anything coming through my serial stream. And with every loop of the update function, it is going to read those printed lines coming from our circuit playground. Next, in order to split up our X, Y, and Z values, because remember they're all coming in on the same line, I'm going to create an array, a string array. So string followed by 2 brackets. Just going to call this sArray for string array. And I'm going to say equals serval dot split with a capital S. And then in between the parentheses, I'm going to add 2 apostrophes, and in between the apostrophes, I'm going to add a comma. So as you may recall, we separated our values by commas. And so what this split function is going to do is it's going to look for those commas and delete them, but wherever those commas are, it's going to add the variables they separate into this string array as individual items in the array. So sArray at index 0 is going to be equal to our x value, and I'm really just doing a comment here. At index 1, it's going to be our y value, and at index 2, it's going to be our z value. So I can say here, xrot equals float dot parse, and what that's going to do is take that string value and convert it into a float. Keep in mind these serial values are coming through as strings and not floats, which means they're being recognized as characters rather than decimal numbers. So float.parse takes that string and converts it into a float so that we can use it for rotation data, which is how Unity interprets that rotation data as a float, not a string. So I'm going to say sArray 0 because, again, that x variable, once you get rid of that comma, it's going to go into that index of 0 of that sArray. And so now I'm going to copy that and turn these into y and z values at index 1 and index 2. So our variables are now set, and we just need to apply them to our cube object. But as I mentioned before, we are bringing in this noisy data. The Circuit Playground has a lot of sensors, but those sensors aren't the highest quality. It's an experimental board. So if you're working on a final project, you may want to have a more robust accelerometer connected to an Arduino, for example. But we're not making a final project. This is just an example. So we're just going to try and smooth out that noisy data. We can look at the rotation value of the previous frame, which is really just our cube's rotation value, and compare that to the value of the incoming frame, which is the value that our Circuit Playground is sending through the serial port. So that value will be our target, and the value of the virtual cube will be our current value. So the current value is seeking to get to the target. So I'm going to create a quaternion. That's quaternion, and that is a 4-dimensional value that Unity uses for rotation. So you've got x, y, z, and a w coordinate. So I'm going to say quaternion target equals new quaternion. And then I'm going to put in my xrot, yrot, and zrot values. And then there's one more parameter, which I won't get into right now, but you can just say 0.0f. It shouldn't really affect anything. So that's our target, and now we can tell our cube to smoothly rotate towards that target. And so in order to affect the rotational value of the cube, I'm going to click on cube here, and you'll notice in the inspector we have this transform block. And within transform, we have our rotation. Because this script is on our cube, all I need to do is say transform dot rotation. So find the transform in the current object the script is in, and then find the rotation. And we will set that rotation by saying equals quaternion dot capital SLERP, slurp, and that means spherical linear interpolation. Interpolation functions are often smoothing functions. They can allow us to take a previous value and a current value and find a smooth way of transitioning between the two. So the current value is our cube's current transform. So again, transform.rotation will give us that value. And then we want it to seek our target value that we just created. So target, then another comma. And then the final value is the amount of smoothing that's going to occur. And because we are doing this in a time-based application, I'm going to multiply by the current time. So I'm going to say time.delta time, meaning change in time, and then multiplied by a smoothing value. And just to make things easier, I'm going to make a public variable for the smoothing value and update this. You may be getting an error here that could be referring to the system.io.ports or serial, and if you are, open up your build settings by hitting Command or Control Shift B. go to player settings, and then scroll down in the other settings area and find API compatibility level. If it's set to Net Standard 2.1, you may be getting an error, so either set it to .NET Framework or .NET Framework 4, and that should resolve any error you're getting. So now I'm going to run this. So you can now see that as I rotate my circuit playground, the rotation of the cube changes to match that. And you'll see there is a slight delay. That is because of our smoothing function. If I bump this up to 0.9, then there's going to be a lot less of a delay and more accuracy. And it's still pretty smooth. You can see the minute shakes of my hand are getting picked up. But if you want a more expressive, drawn-out delay, if I bring that down to 0.1, it's going to take quite some time to catch up to the actual position of the circuit playground. So that's it for today's tutorial. Keep in mind that you can take any data from the circuit playground and transmit it via that serial function, and then receive it in Unity and use that data for anything your creativity will allow. So maybe you want to take the temperature data and have that affect the climate of your virtual application. Or maybe you want the amplitude coming through the microphone to creatively use sound input in Unity. Or you might use the capacitive touch sensors to create a custom video game controller. It's really up to you, but I hope this tutorial has demonstrated that it's all relatively simple. You're just grabbing data from the circuit playground, labeling it, and pushing it through serial, then essentially decoding that serial to be used as variables within your application. Thank you for watching.